So thank you very much for Andy to be the speaker, and we're very honored to have Andy to share with all of our members, of the AI development, what sort of AI and tax would have in the coming future. So I'll just pass the time to Andy to share your experience and content in the coming 40 minutes or so. Over to you, Andy. Thank you.
Thank you, Desmond, for the introduction. It's really an honor to be here. I hope everyone can see my slides. So today I'm going to talk about AI and tax. And I got a lot of slides that you see. So some of the slides I'll go through very quickly. First, to give some context where we are. So a lot of people say that we are now in the age of the fourth industrial revolution. So of course, the first industrial revolution is about probably over 200 years ago with the invention of machines and steam engine. The second industrial revolution is the invention of the assembly line. And then the third industrial revolution is the computerization use of robots in a factory. And the fourth industrial revolution, which we're currently in, is an interesting time because every time there's a new set of technology, it empowers the industry to produce higher quality products faster and cheaper. So what the current fourth industrial revolution includes technologies like IoT, AI, machine learning, as well as 3D printing. So you can see we have new 3D printed products, 3D printed jewelry, even 3D printed houses. Some people also call this current time the Web 3.0, the age of Web 3.0. And it's interesting because the history of web is actually very short. We only had internet roughly 40 years ago, and then we have web, World Wide Web only 30 years ago. I can still remember the time when there was no web. Any of you remember when there's no web? No, I'm sure a lot of you are much younger. And then back in Web 1.0, it's basically a static website. You can't do anything but this is like a book. And then Web 2.0, which is roughly 20 years ago, is where there's a more interaction. So you can fill in forms, and most importantly, you can start to create content and use social media. So where we are now, Web 3.0, it is the next stage where things are being decentralized using technologies like blockchain, distributed ledger technology, much more trustworthy. And all these new technology combined together is empowering us to do a lot more. We are, of course, also at the age of COVID-19, and that's very important because COVID-19 have caused a lot of companies to really seriously look into digital because companies that are not online and does not have a digital presence are disappearing very quickly. So COVID-19 has a big impact to the way we work and live. Work from home, and then the way we live, a lot of things we order online now. And COVID-19 is the main accelerator for digital transformation. So digital transformation is also a term that we use to explain where we are currently at. And digital transformation basically means using digital technology to transform the company so that you can produce products and services more effectively, more efficiently. And digital transformation usually have three phases. It starts with digitization, making sure everything is, you have data and information, everything is paperless. The second is digitalization. Once you have data, how do you use that data to automate and streamline your process? But the most interesting part is the last stage, digital transformation. How do you transform your company, transform your business to be able to offer new products and services that was not possible before? Now, the technology behind a lot of these things, the fourth industrial revolution, the Web 3.0, the digital transformation, the technology that drives all these things are mainly data and AI. And some people say data is the new oil, so it's the fuel that drive things. And data, by data we mean big data as well as data analytics. And some people say that AI is the new electricity because you can just you cannot power a electric appliance with oil. You need electricity. So data is AI is the new electricity, means AI makes the data intelligence more useful. So AI machine learning allows us to use data to get insights, actionable insights that we can use to improve processes, as well as improve productivity and understand our customers better. And today I'm going to give you some examples of how data and AI is being applied to the tax industry. And before we do that, some common examples of how AI is used in daily life. Of course, self-driving cars use AI, computer vision to figure out where you are, where you're headed, and to control your cars. Face recognition, of course, is a very popular application of AI in daily life. Speech recognition, of course. And then, of course, one of the most common use of AI is in chatbot. This is a chatbot by MTR, where it gives you instructions. But not all AI is good. So, deep fake, where you produce fake video of celebrities or politicians speaking, that's also AI, unfortunately. Now, AI is not new. It's been around for a while. So typically we say that AI has three waves. Because this is computer science, we start with zero, wave one, and wave two. So three waves. And this is roughly 60 years ago. This is where AI started. And back then, the applications are simple, handcraft. I mean, you had to do all the programming. And we tend to call these, toy problems. This is where AI got started. A lot of different algorithms and theories were invented back 60 years ago. Unfortunately, after that, there was an AI winter. AI winter is a term we use to describe situations where businesses, commercial and funding kind of died down because of lack of interest. And what happened was that at the early days, a lot of AI practitioners overpromise what AI can do. And then people got disappointed, and then the funding and interest for AI died for a few years. And then 30 years ago, there's a second wave where we invented even more powerful algorithms for machine learning and natural language processing. So engineers created statistical models for specific problem domains and trained them on big data. And this is when we created algorithms like backpropagation for neural networks. But unfortunately, hardware, the software was there, but the hardware was not yet available because it was quite expensive to process these machine learning. So there was a period of AI winter again. And then roughly 10 years ago, interest in AI started again because we have cloud computing that offer cheaper data storage, because with AI machine learning, we need a lot of data. So with cloud computing, data storage was cheaper, as well as processing capability. And that allowed AI to do things that's more interesting, using real world data and then lots of real world data. And that's why the current wave of AI has been so successful. But AI is not just machine learning. This diagram shows you machine learning is only part of AI. And even in machine learning, deep learning, which is like face recognition, which is very popular these days, is only a part of machine learning. There's other types of machine learning as well. And then, of course, there's also natural language processing, machine translation, question answering, chatbot is part of that. Expert systems are rule-based systems. These are more traditional type of AI. And then, of course, computer vision, face recognition, image recognition, and robotics. There's the hardware robotics, but recent years we have robot process automation, which are software robots to do mundane tasks that humans don't need to do. and then speech, speech to text, text to speech, as well as planning optimization. Now, one type of machine learning is deep learning, and one model of deep learning is called GPT, generative pre-trained transformers. And these models mimic humans in natural language understanding, and they can also generate text by themselves. You can also be creative and generate different images and all sorts of interesting creative output. And the reason I want to show you this diagram is the size of this artificial brain that we're creating. So a few years ago, it was relatively small size, but as we as technology improves, as hardware gets cheaper, this artificial brain size has reached to just a couple of years ago, GPT-3 has reached to 175 billion parameters. These parameters are basically like synapses in the human brain, or mimics synapses in human brain. And then the Google brain is 1 trillion of parameter. The human brain size is off chart, but we envision GPT-4, which will be out later this year or next year, will have the same complexity as a human brain. So it's going to be amazing to see what happens later on. So where are we at in artificial intelligence development? Some people say that AI can be divided into 3 stages. The first stage is AI narrow intelligence. What that means is that it can only do specifically focused tasks without ability to self-expand functionality. What that means is that it can only do something very specific. Anything outside what it's trained to do, it will not be able to perform. Next stage is artificial general intelligence. And what that means is that it's like humans. We could do different things. I mean, we could eat, we could talk, we could watch TV. So it's not only a specific task, but a broad range of tasks. And could reason between those tasks, maybe improve our capabilities. So it's going to be comparable to humans. And then the last is artificial superintelligence, where AI is going to be more intelligent, many times more intelligent than any human being. And artificial superintelligence we will explain as AI as smart as all humans on this planet combined. So that's amazing. So today we're basically still at this initial stage, artificial narrow intelligence, and maybe general intelligence around 2040. And then soon after general intelligence, it'll be super intelligence. Some people say it's going to be the year 2045. And that's when we reach digital technological singularity. And it'll be interesting to see if those predictions come true. Okay, let's take a break and do our first polling question. Can the Secretary Office show the first polling question? So the question is your company using chatbot or robot process automation? If you're using chatbot or robot process automation, say yes. If you're not using any of that, say no. It'll be interesting to see how many companies are using these technology, which is pretty popular these days. Okay, let's see the result. Oh, interesting. So a majority of you have your company that you work in are not using robots or robot process automation. So chatbots, of course, that you talk and get answers, and usually very often used for customer servicing. Robot process automation is something to automate the backend processes so that humans don't have to cut and paste and move between applications. These two technology are well understood, and it's easy and it's very low risk to use. So you might consider that later on if you wish. Okay, interesting. So back to the core topic of today, AI and text. So actually, there's a lot of application of AI in text. First of all, some of you may know, China's golden text 4 system will be released this year, and it uses big data and artificial intelligence. This is an article from January of this year. And what it does is it's used for the National Value-Added Tax Administration and Monitoring System. It manages text through big data. It monitors text and non-text data, such as social insurance, and data collected from banks, ministries, commissions, etc. So it compares and checks data submitted with bank accounts of taxpayers, related company personnel, upstream, downstream companies, and revenue costs and profits of the same industry. So what that means is that it's collecting data from many different sources and using big data and AI to correlate and compare to see if there's any mistakes or make influences on structures, company structures, personnel relationships, etc. So big data and AI through China's golden text system 4 can probably do these things. These includes identify false bank accounts, false invoices, abnormal tax declarations, abnormal tax burden rates, mismatch between income and costs, inventory books that do not reflect actual arrears of individual income tax and social insurance premium, shell enterprises, perennial loss making, but never fail. And I love this picture from South China Board Post that it kind of explain what this golden text 4 is, but looks like an MRI machine. But with MRI machine, you're not supposed to wear anything metal. So this is the reason why he's getting a headache. Okay, so this is a first example use of AI is using big data. So we can connect the dots between different data sources to verify if the information is truly correct. Now, the challenges with big data, using big data for this is because it's trying to connect the dots. So one of the first challenges is, do you have the dots? Do you have the data? Do you have the data sources, the data sets? So it's important, and you're able to use a big data AI, you first have to make sure that you have access to all the necessary data. Otherwise, you're not going to be able to connect it. And then you need to make sure that data is indeed correct. Otherwise, you'll be connecting the wrong dots. So increasingly, data governance is important. Data governance ensures that the data you get is correct, it's been cleaned, it's been verified, so that when you do make any influences, it's going to be correct. Now, the golden tax system is part of the State Taxation Administration for the People's Republic of China. And there is a new tax reform that was announced last year. The tax reform is called Opinions on Further Deepening the Reform of Tax Collection and Administration, which I'm sure most of you already know. It's China's smart taxation. The first reform was in 2015, second 2018, and this is third reform. The main objective for this new tax reform is high quality, high efficiency, and intelligence. So intelligence is very important. Greatly simplify and streamline processes, data sharing across government departments with state and local as well. Instead of declaring and paying 6 types of taxes separately, just one form, everything's online, mobile, contactless, and non-face-to-face. So you could do everything through your mobile phone, for example, if you're doing personal tax. Everything's personalized with AI and big data. So this is a key thing, is that they're upgrading also the technology. Here's an example timeline. So there, the document that China released has many timelines. So this is one example. How to improve ways of dealing with taxes and fees. So by last year, enterprises can do most tax and fee matters online, individuals via smartphones. This year, there'll be the unified and standardized electronic tax platform. And then tax and fees processing contactless. So they always emphasize contact-free and non-face-to-face manner. What that means is that you can pay and do everything from your mobile phone. By next year, automatic extraction of data, automatic calculation of taxes, and automatic pre-population of tax forms. So if you're a individual, when you get the form is already filled in, all you do is take a look, and if it's okay, you press a button and then pay via your smartphone. It also mentioned a lot of technology upgrade. So they want to accelerate the building of smart taxation using big data, cloud, AI, mobile, and integrate internal, external data. Of course, they've been China's been rolling out e-invoicing or e-fapiao for many years. So this is so this year they're going to roll out a new version that's fully digitized with 24-hour service. And they'll be deepening sharing and application of big data. And they mentioned the use of blockchain technology to explore social security contribution collection and real estate transaction and registration. So blockchain, I'm sure a lot of you hear the name blockchain. So blockchain is a type of distributed ledger technology. It allows multi-parties to share data in a secure and trusted environment. And that facilitates very quick and easy data sharing and ensuring that the data that you do share is indeed accurate. So benefits of AI. So by this year, provide intelligent and personalized service, 24-hour intelligent consultation service. So it's like a chatbot, big data analytics to personalize user experience based on taxpayer needs and provide targeted online service. So what that means is it's similar to a lot of personalized websites. So what it does is that, for example, if you are a young single person, when you go into the tax website, you get information that's relevant to you compared with someone that maybe is older and married, for example. Tax authorities will support third parties in providing taxpayer with personalized service, so allowing taxpayer to access third-party services as well. And then business secrets and personal privacy should be strictly protected. So with that example, we're adding to our list of uses of AI in taxation. So we already talked about big data, connecting dots with with the golden tax system. And then with the tax reform, you get more accurate, efficient, and intelligent system, improving transparency and consistency because state and local or offices share the same data. There's AI chatbots for 24-hour service, AI personalization, better and more relevant customer experience. So those two examples already give you quite a lot of applications of AI. Now, China is not the only country that's using AI big data for tax. US IRS is also using big data for a similar purpose to connect the dots. In IRS, they connect the dots in millions of tax filing to find potential tax cheats. The data they have includes bank transactions, phone records, social media posts, etc. They even have access to text messages, passport numbers, criminal histories, and then mother's maiden names, etc. So an example use of AI is that AI can detect if a taxpayer, for example, moves assets from a European bank to Cayman Islands and then use ATMs to withdraw cash to purchase a second home in Florida. So it's a kind of money laundering where you're trying to get money from Europe and then be able to use it in Florida. Another example is AI can catch someone who claims a certain deduction in tax filing and then post pictures on social media that contradicts that information. For example, if you're claiming deduction that you are low income, but then you show pictures on your social media where you go on vacation and buy expensive goods, then IRS would know. In UK, Her Majesty's Revenue and Customs also has a system to catch tax dodgers. It uses billions of data points to find relationship between people and organization. Australian taxation office also has a big data platform that helps its tax avoidance task force to find complex and multi-layered relationship between clients. And one of the technique they use is called a graph database or a graph algorithm. Graph is one type of AI knowledge representation. To give you an example of what a graph database look like is that it's basically a graph of nodes that could be anything. And here it says people, and then links of relationship. So here you say, Queen Elizabeth II is the parent of Charles, Prince of Wales. Prince Philip, Duke of Edinburgh is the parent of Charles, and so forth. So these are relationships. And AI and big data could come up with all these relationships between different people, different organizations, different shareholders, different directors, etc., to find if there's any tax avoidance. Another use of this graph representation is in TurboTax, which is of course a very popular tax software, and it uses graph to encode knowledge about how taxes are calculated using, they call it this calc graph. And the most important thing is that it could use this graph to explain what's going on. So for example, here, the explanation for this node is that LO line 20 is a result of subtracting line 16 from line 19, for example. And with this structure, you can answer questions from taxpayers, like, for example, how did you calculate $500 as a maximum allowed for the other dependent tax credit? So this ability to answer questions by looking at the graph is very useful. So knowledge graph is another application of AI in taxation. Encode knowledge and generates explanation. And then of course, AI is always, it's good for natural language processing. It's good for intelligent search. So a common use of AI is in tax research, where there's so many tax laws that you need to search, so many cases, precedents that you need to look for references for similar cases. And many companies have similar products for research. Thomson Reuters have this Checkpoint Edge. Walter Kluwer has his CCH Answer Connect. And it's basically leveraging the natural language processing capability to do intelligent search and help people with text research. Okay, let's see how many people are using that. So this is our second polling question. Are you using AI for intelligent search or text research? Yes or no? Okay, let's see what's the result. Again, it's a similar result. So I guess companies that are using AI for chatbots or RPAs also using AI maybe for intelligent search. 14% compared with 86% not using. Okay. Another example of how to use AI is, this is a very interesting software. It could, given a particular tax law legal case, it could predict 90% with 90% accuracy the outcome of this legal case, and this is for Canada. So this AI can predict legal case outcomes at 90%. This is how it works. So you select a legal case scenario. So what that means is that what is this legal case about? So is it about real estate, or is it about, I don't know, investment or whatever? And then you fill in a questionnaire identifying relevant facts, and then AI analyzes all prior case laws and rulings and makes prediction about your scenario. So it compares all the relevant cases before, and as well as relevant laws. And interesting, it also provides an explanation why, it predicted this outcome. On top of that, you could do what if analysis. So you could say, what if this factor was different, and then with playing with the factor, you could figure out what is most important that influence the outcome of of being positive or negative. So this is another use of AI in taxation. It's predict and explain legal case outcomes, and allow you to do what if analysis to see what are the important factors. Now, not all AI applications are smooth. So end of last year, this news article is from November of 2021, and US IRS said, in the future, everyone logging into their online system must use facial recognition to log in. And that's November. By February, within like 2 months, it already reversed that to say, no, we're not going to do that because a lot of objections using using face recognition to log into IRS. Why? What's the reason? I mean, face recognition, logging into a cell phone is very common. It turns out there's many different types of face recognition. So the type of face recognition you use to log into your Apple iPhone is different from the one that IRS is thinking. So in IRS, it's not one-to-one face match. This is what like iPhone does. You match your face and then you log in. It does one-to-many. What that means is that each time you log in, compare your face to the many other faces to see if you have logged in with a different name or potentially other things. So this is what scares people. They use their face for other things. And then there's unclear AI bias. So if you do one-to-many, it's not always accurate. And there might be AI bias. Well, AI bias means it might not be accurate for people of different race. It might not be accurate for people of different gender, for example. And on top of that, the vendor has a right to share the collected data with the police, other government departments, and other selected partners. And this disadvantage elderly and lower income households who doesn't have smartphones. So there was so IRS quickly backtracked and said, oh no, you don't have to use face recognition. So another application of AI is face recognition, but I put a star there. There is many concerns to do that. Now, since I mentioned AI bias is something that is very important that I just want to speak a bit more about. So what is AI bias? Means, AI bias is like human bias. We sometimes, depending on a person's gender, race, or even religion, AI may perform differently. So this is a study a few years ago, 2018, where MIT tested several face recognition software and found that if you're Caucasian, the accuracy rate is the error rate is only 0.8. But if you're a dark-skinned woman, the error rate is 34.7. So what that means is that it would misidentify a Black female a lot more than a white individual. And this is dangerous for applications if you're using it for criminal identification. It will identify wrongly females more often. Another example of AI bias is in Amazon, where they created an internal AI tool to read resumes for people who are applying to jobs. And turns out it rejected a majority of women. So whenever a woman applies for a job, the AI software most likely will reject that just because there's a word woman in the CV. And that's because a lot of tech jobs in the past were men. And AI machine learning somehow learned that women should get a lesser chance. So this is of course discrimination, and Amazon quickly scrapped that project. Another example is this is used in the United States criminal system, and it tried to decide when you sentence a person, it uses AI to help with sentencing. So it would ask AI, what is the likely chance that these guys would reoffend, recommit the crime? If so, the sentence might be longer. And it found that given the same background, it always recommended a longer sentence for the Black individual. And then Facebook also had this problem with discrimination against gender and race. For example, if you advertise for jobs, certain job like a waiter, so it would probably recommend female. Different type jobs, for example, maybe janitor recommended for men. And then if you are trying to post a ad for a house rental, if it's in a white neighborhood, they only recommend white, and so forth. So it was a problem that supposedly Facebook has fixed already. The AI bias could be in medical. So this is a system that's used by, I think, like 200 million patients. It's used to recommend how much healthcare to give, and it always biased towards white. So white would get more healthcare compared with blacks. So the AI bias is a big problem, and it's bad. So in text, why is it bad for text? So there could be AI bias in text. For example, it may recommend females to pay higher tax. That might be bad, or it may give incorrect tax suggestions for people who are living in rural areas because we don't have enough data for machine learning, and so forth. So the lack of data may cause AI, when used in text, to discriminate according to gender, male, female, maybe according to race, according to where you live, for example. So that's really bad. So when we develop AI programs, we have to make sure that we have enough data for all the different types of people that we're serving, as well as making sure that the model we design has no inherent bias coded into the model, and the attributes we use do not consider things that might cause bias. For example, do not consider factors like women or men when you're analyzing CVs, for example. Okay, the last topic I really want to cover is metaverse, because I think any talk these days, if you don't mention metaverse, then it's not really up to date. So metaverse, I'm sure most of you probably heard metaverse because Facebook changed its name to Meta, of course. What is the metaverse? Metaverse is a very immersive 3D environment. This is me in Decentraland, and this is me in the sandbox. In the metaverse, you can buy a lot of things as digital. So, for example, you can buy this Gucci bag in the metaverse for $4,000 which is more than the real bag. In the metaverse, you can buy a big gigantic yacht. This is sold for $650,000 in Sandbox. And you can buy artwork. So this sold for close to $70 million at Christie. This is your art. And we call these digital assets ETFs. You can buy land. So every REM bought land in the Sandbox for a record $4.3 million, the most expensive so far. The Sandbox is actually is one of the largest metaverse companies based in Hong Kong. And famous architects are also designing cities and buildings in the metaverse. This is Zaha Hadid architecture firm designing a city. So why is the metaverse important? Because people will have more and more digital assets. People will have more and more crypto currencies. And IRS in US say that cryptocurrencies, virtual currencies, are indeed taxable if you sell, exchange them, and gain in profit. So this is something to be aware of in the future for tax professionals is highly expensive digital asset and then cryptocurrency. I want to end with this last question, which everyone always asks me is, will AI take my job? What do you guys think? So I'm not really smart enough to answer this question, so I'm going to invite someone else to answer this question. I'm going to invite Albert Einstein, because he famously said the hardest thing in the world to understand is the income tax, because even Albert Einstein couldn't make sense of income tax. So with that quote, it really means that income tax or tax in general is a very complex profession where there's a lot of legal legislation and things changes over years, a lot of complex relationship and so forth. It's at the current state of art in AI, it's hard to replace tax professionals. However, Martin Fiore said that 80% of the tax function's time is spent in gathering data and only 20% in analyzing it. So what AI does do is help you invert that so that you could spend more time doing real work rather than just analyzing or just collecting data. Thank you for your time. This is all I have. Welcome any questions. Back to you, Desmond.
Thank you very much, Andy.